Hello friends, welcome to Shiksharthi. In this session, we shall be discussing how to find out whether a given triangle is an obtuse-angled triangle or not. So let's start. Now the prerequisites for this session are you should know how to find out whether a given triangle is an acute-angled triangle. Second, which is a prerequisite for how to find out whether a triangle is an acute-angled triangle or not, is you should know the criteria you should know how to find out whether Hello friends, welcome to Shiksharthi. In this session, we shall be discussing how to find out whether a given triangle is an obtuse-angled triangle or not. So let's start. Now before we start, the prerequisites for this session are you should know the law of similarity, congruency, perpendicularity and parallelism, right? Along with this, you should know how to find whether a given triangle is an acute-angled triangle or not, because that is a stepping stone for this session. Now here what I am doing is I am drawing a triangle with vertices x, y, z. So please appreciate that it is a freehand drawing. Now when I say law of perpendicularity, you would see that in most of the cases you will be required to either draw a line parallel to a given line, or you will be required to have a pre-thought that you're supposed to draw a line which is perpendicular to a given line. Now in this case, we have assumed a point W which is lying outside the triangle, and XW is the perpendicular that we have drawn. So using Pythagoras theorem now, so let's say Pythagoras theorem. So using Pythagoras theorem, can I say that in triangle XZW, W is the right angle? So can I say XZW is a right angled triangle? That is correct. And why are we able to say this? Because the angle XWZ is equal to 90 degrees and the remaining two angles, which are angle Z and angle X, lying inside XZW, would be acute angles. And when we are finding whether this given triangle, which is XZW, is an obtuse-angled triangle, there are two ways of doing this. One way is you find it out with the measure of angles, by the measure of angles, in which exactly one angle should be an obtuse angle and the remaining two angles would be acute angles. That is one way of finding out whether the given triangle is an obtuse-angled triangle. But here in this session, we are not talking about that, because that is a method which is very obvious. We are talking about a second way in which we can find out whether a given triangle is an obtuse-angled triangle, that is with the help of the measure of its sides. So coming back, in the triangle XZW, can we say that XW whole square, which is perpendicular whole square, is equal to the difference between the square of its hypotenuse and its base? Similarly, can we say that in triangle XYW, which is again a right angle triangle, can we say that XW whole square, which is the perpendicular square, is the difference between the square of its hypotenuse and the base? So the base here is YW. Let us say that this is equation 1 and this is equation 2. So from both the equations we are able to equate their right hand sides, because in both the equations their left hand sides are the same as xw whole square. So can I say xy whole square minus yw whole square is equal to xz whole square minus zw whole square? Yes, of course. Now from here we can just articulate and we can come down to a conclusion which says xy whole square is equal to xz whole square, and then I am combining the remaining two here. The remaining two here are yw whole square minus zw whole square. Why have I done this? I have done this because the points y, z, w are collinear. Why are they collinear? Because they lie on a straight line. Conversely, if there are 3 points collinear, they would lie on a straight line. And now I am using the outcome of an algebraic expression. For example, a square minus b square can be written as a product of its factors, and the factors here incidentally would be a minus b and a plus b. Using this, we will be able to infer that xy whole square is nothing but xz whole square plus yw minus zw and then yw plus zw. So yw minus zw gives me how much? So can I say that this directly gives me something? Yes, this directly gives me what? It gives me yz. So finally, can we say that xy whole square is nothing but xz whole square plus yz now, and then yw plus zw can be written as yz plus zw, which makes it twice of zw. So which eventually can I write, eventually after this can I write xy whole square is nothing but xz whole square plus yz whole square plus twice of yz into zw. This is the final outcome that we get from here. Now the final point which arises out of this discussion is, we know that we can find whether a given triangle is an obtuse angled triangle in two ways. One is by the measure of its interior angles, each of its interior angle, or by the measure of each of its three sides. And incidentally here we are talking about the difficult one, which is by the measure of its side. So let us see in this case, when we are talking about how to find whether the given triangle is an obtuse angled triangle by the measure of its sides. In that case, do we know the sides? So let's assume that this side is A. We are talking about the length of xy being small a, the length of xz being b, and the length of yz being c. In that case, we do not know the value of ZW, which we are assuming here to be X. Let us see whether we can find out these. So now coming back to equation 1 and equation 2, can I get the value of XW given that XZ is known to us and we have assumed ZW? Yes, and then we substitute it in the second equation in which XY is already known to us and Y is, now when I say in substituting it in the second equation, XY is already known to us, right? And can I say YW also is known to us? Yes, because YZ is known to us and we had already assumed the value of ZW. So in that case, we get the value of X, and once we get the value of X, we get the value of the line segment ZW. So hence we come down to a conclusion that in case if this we are able to establish, if we get the set of values of XY, XZ, YZ and ZW which are able to satisfy this given equation, that means the said triangle that we were discussing is an obtuse-angled triangle. Now, as a learner, you are expected to prove this, because this proof or this concept will be used as a lemma in many other concepts of geometry and trigonometry as well.